Okay, everyone, just stay tuned. Just about after 7 to 8 minutes, we'll start off with the session. Just stay tuned. Okay. And guys, if you have any friends who are interested in doing data science as their career, who just want to know a little bit about this topic, you can send them this link. They can join and they can also know a little bit more about this topic. Okay. Okay, so good afternoon, everyone present here. How are you all? So, on behalf of TCP and IT Raipur, I, Gaurav, along with the coordinators and my whole team, would like to extend a warm welcome to you all. So, basically, today we have gathered here for a session on one of the most talked about topics in the tech world, which is data science. I mean, the power of data has no limits, and the recent events have proved that. I mean, it has become the new oil, and the proper analysis and research of it has become, I mean, one of the major reasons for any company's success. Be it any company, data has become the root all for it. So, data science as a career opportunity, it also offers a huge set of advantages like lucrative salaries, exposure, the zeal to learn more and more, amazing work life balance, great connections, networking, and a lot more, which will be discussed soon. So, today for this, we have an amazing person with us who will talk about this topic in huge detail. So, we have Sajjad Hussain with us. He has joined us live from Canada. A big welcome to you, sir, and thank you for accepting our invite on such a short notice. So currently, he's a manager at data science at Trafigura, Canada. He's the co-founder and data science lead at Heuristech Labs, and he has done his bachelor's of technology from NIT Kurukshetra, and has also worked with amazing companies like Morgan Stanley Capital International and eClerx. So we'll start off with the session. So, but before we start off with the session, we would like to take a little time and thank Algo University, which is our title sponsor. So, basically, it is an online academy which focuses on training the students by providing them online lessons on topics related to software engineering, DS Algo, etc. So, as a vote of thanks, we would like to play a minute long video on it. Okay, so that was wonderful. So now, without any ado, I call upon Sajjad sir to straight away start off with this amazing session and enlighten the audience with the world of data science. So, guys, the diamond is here. Make sure you use it well. Let us begin. Over to you, sir.
Thanks, Venkatesh. Thank you for the nice introduction. Hello, guys. Morning to everyone. So we'll start off in a minute. Let me just try sharing my screen. Okay, perfect. Venkatesh, can you confirm if you can see my screen?
No, sir. Right now, I cannot.
Is that so?
Yes, sir. Yes, sir. Now I can see your screen.
You can
Perfect.
see? Okay, okay.
Yeah.
And is there any lag in my audio or any noise or disturbance?
No, no, no. Your audio is
Perfect.
good.
Okay.
Perfect.
Okay, so I'll start off, and again, very good morning to everyone. I welcome all of you to the session. We are going to quickly go about and talk about the topic which we have discussed, and we will see what data science is and all those things. But before we do that, I would just like to set an agenda for this whole session, okay, so that we know like what you can expect out of this. As Venkatesh has given a very nice introduction, so I'd just like to add a little bit on top of that, so. Just to quickly introduce myself, I am currently working with Trafigura, which is a commodities derivatives trading firm, and I worked here as the lead data scientist, and I have been associated with this firm for the last 3.5 years. And before that, I have experience working with different fields and different companies in different domains. I worked with firm called eClerx, which was into consultancy domain, and then I also worked for the government like CSIR, and then I've also worked across other organizations like in investment banking. Now, the idea of telling you this is like my career throughout these years have been into different fields and domains, and I have seen data science evolve throughout my career. So it's not like data science is not like an exact science, to be honest, where we can define things in a way like this is what you need to learn, or the syllabus or course which you can do. Although there are a lot of people who offers courses, and like you will see online a lot of advertisement and all, and you might be like curious about those things. So since I've seen this whole field grow, also I'll talk through the journey. So the idea of sharing this, having this session is basically sharing my journey. And of course we are going to talk about data science, of course we are going to talk about technologies, of course we are going to talk about algorithms and all those sorts of things. Okay. So now, having said that, let's quickly start with that. And within data scientist, we hear these terms, what we call as data science. Sometimes we hear some other terminology. Some people say AI, artificial intelligence, or someone will say to tell you machine learning or anything like that. Now we'll try to understand what all those things are. We'll also try to understand what are the differences between these, and we will also try to get into deep dive a little bit into like what are the things which you required, which you are required to learn if you want to get into this. Now, it doesn't mean that in this course of 2 hours we are going. I'm going to make you a full stack data scientist. No, if you are coming with this objective, then you should drop out. So nobody can teach you data science in 2 hours, or let's say even 2 months. Okay, so it's a very learning process which you will accumulate over a period of time, and the more you learn, the more you practice, the better you're going to get. Okay, so if I'm not going to teach you complete data science in this whole session, then what am I going to do? So what I'm going to do is I'm going to make you understand what data science is, and I'm also going to make you understand if data science is something which you might be interested in as a career or not. Okay, so I know that all of you are students at this point of time. You might be wondering about your career, and maybe because you have started, you are new, you are young, so I can understand from your point of view. So if you want to get into this field, let me tell you that maybe it might sound very attractive and lucrative these days, but it doesn't mean that this is the only career which you have. I mean, like, you can be whatever you want. I mean, like, you are at a stage where you can learn anything. So this is one of the options. So I'll try to explain this option to you, and later on you can decide whether this is something which interests you, or maybe you can just decide the other way around also, like whether this is something which you don't want to do in your career. Okay, so that is the whole aim of this session. Okay, now coming to set a very brief agenda of this whole session, we are going to cover these four topics. So we'll start off with fundamentals. So we'll start off with very basics of the definitions. We will also look into not only just the definition of data science, but we'll also look into the definition of different terminologies utilized, like what exactly is machine learning, what exactly is predictive analytics, what exactly is prescriptive analytics. So we are all these terms. We'll try to explain all of these. Okay. Then we will also look into like what are the skill sets required for data science, and we will see that one of the core skill sets is basically programming. Now there are many programming languages in which you can do data science. I mean, there is no restrictions as such, but Python has come out in the last few years. Python has come out to be a leader in this field. So we will do a little bit of little bit of introduction into Python programming. So that's also something which we are going to cover. And the next thing which we are going to cover is we are going to look into some of the algorithms. Now, we usually say machine learning algorithms, but again, you don't need to worry about what exactly machine learning algorithms is. You just need to understand something like this is some algorithm, and we will look into like what exactly is machine learning, or what exactly is predictive analytics and all those sort of things. Okay. Oh, sorry. One second. Yeah. Okay, and finally, towards the end of the session, probably we'll try to target the last 45 minutes or so into something what we call as the implementation part. And when I say the implementation part, what I actually mean is we are actually going to try some hands-on coding. We are going to use Google Colab for that. And when I say Google Colab, it's basically a browser-based solution. So if you are with your laptops, I would prefer that you guys go along with me and try to replicate that. You don't need to install any software in your laptop, so that is not a prerequisite. So you can just do it all in your browsers. I'm going to help you out on that, like how you are going to do. But if you do that along with me, it's definitely going to. But even if you are not available with your laptop, even if you've joined using your phone, that's fine. You can always check the recordings later, and you can follow up from that. Okay. So that's the whole agenda, and now we are, I think we are ready to move on to our next section, where we are going to discuss about exactly what data science is. So let's discuss. So the first question which I'd like to answer is, what exactly is data science? And a lot of people might ask you, or maybe if you are interested, or even you might have this question. So a lot of people do ask me, like, what exactly does data scientist do? So some people has this crazy idea that, okay, a data scientist is a guy who's basically a scientist, or maybe who looks someone similar to Einstein, have long hairs and all those sort. It doesn't. No, it's not true. It's completely false. So what exactly a data scientist? And then maybe someone might have an idea, but okay, maybe a data scientist is a guy or a girl who basically builds fancy algorithms, or maybe do a lot of programming, or maybe solve very highly technical questions what you see in movies, something like that. Again, partly true, not completely true. Then if those are not true, what exactly does the data scientists do? So the simple answer is, data scientists solve problems. Okay. Now what kind of problems do we solve? So what we solve problems which cannot be solved by traditional methods. Now whenever you have a particular type of problem, so let's say I tell you a problem of making coffee. Okay. So when I ask you to make a coffee, there could be two ways to it. One could be, someone gives you a set of instructions to make a coffee. Like, you can ask someone, okay, can you please tell me how to make a coffee? And someone will tell you, okay, take some milk, take some coffee powder, mix some sugar, heat them, and then drink it. That's how coffee is made. That could be one way of doing this. So this is the traditional method. Okay. And the traditional method is basically what we call as a rule based method, and that is what has been ongoing for many, like, few decades, at least, in almost all of our problems. Like, we have a solution, we know the solution from somewhere, and we try to program that. So we try to program those rules, and that is what we call as a rule based approach. Okay. Now how a data science will solve the same problem of basically making a coffee is, we would not tell them what to do. What we will do is, actually, we are going to give them data. What data would be that? The data would be that there could be many steps involved, and with each step we will tell them that whether it is part of making coffee or not. So someone might tell, okay, heat water, this is one step. Then another data would be like, okay, heat milk. Another data would be cool milk. Another data could be like walk. Another data could be rain. Another data could be like shout. Okay, so all these are data, and with each data there could be something like, okay, this is a part of making coffee, this is not a part of making coffee. Okay. Once we provide this, okay, walk is not a part of making coffee, or like cooling milk is not a part of making coffee, heating milk is a part of making coffee. Okay. So these, once you provide this data, and then by this data, if we ask someone to learn automatically how to make coffee, and if that process is what we call as basically learning, or we call it as a machine learning, because a machine tries to learn something from this. Okay. So this is basically, again, an approach to solve the same problem, but a data driven approach. So an approach where we are trying to utilize data to solve the problems of our daily life. Okay. Now I gave you an example of simply making coffee. The example could be many different types. So the example could be like anything else. Like, it could be an autonomous driving. You see Tesla cars. Okay. So those are autonomously driven. Now I gave you a very simplistic example of making coffee. Just try to extrapolate the same phenomena in automated car also, right? And exactly that's what happens. Like, it's a bigger problem, it's a more complex problem, definitely. But what happens there is, again, to automate a car, to make a car which can drive by itself, either there could be, again, two approaches. One approach could be, we can simply write certain set of instructions to the car. The instructions could be simply like, when you see some obstacle, when you see a human in front of you, stop. This could be one instruction. Then take right, after 90-meter take left, after then take a u-turn. These are the set of instructions, right? So this is the rule based approach. But you know that this will not work in real world problems, because you can write as many instructions, like, okay, after 90 meters take right, but you don't know what will happen actually in the real world. Maybe you have told the car to take a right, but when the car was trying to take a right, it found another vehicle in front of it, so the car will crash. So that's where data driven solutions comes in, where thousands and thousands, or not even thousands, billions and billions of data will be provided to the car, and the car will all the, or the algorithm will itself learn how exactly to drive a car without crashing it and still reaching its destination. Okay, so this is basically what I'm trying to tell you is, at the end of the day, even the data scientists solve the same problems which other people were doing. The only difference is data scientists try to solve these problems using a data driven approach, and there are a lot of problems which cannot be solved by the traditional approaches, and which we are able to solve using data driven approaches. And that is the reason that in the last decade or so, data science has completely taken off and it has become so popular. Okay, perfect. So now once we have understood what we do, what data science is all about, what it does, we are going to look into certain applications of it also. But before doing that, I'm just trying to summarize in terms of how does a day-to-day activity of a data scientist looks like. Okay, so now let's say if you have made up your mind and decided, okay, yeah, you do want to become a data scientist, and you learn about it. Okay, now you have learned about data science. You let's say you are a good data scientist, and now you are ready to join a job. You join a particular company. You might be wondering, like, what exactly I will do there, what exactly would be my role at that particular company. So this is, I mean, like, it varies from person to person, it varies from company to company. Data science itself is a huge field, so there could be like multiple subdomain within that, so that also could be one of the factor what you will do. But broadly, you are going to do at least these three things. Okay, what are those three things? First thing is, you are going to become a business analyst. Business analyst is a person who is going to talk to the business people, talk to the business management people, and then try to understand a particular business problem. And then once you try to understand a particular business problem, you try to convert that business problem into a technical problem. Okay, so what I'm telling you is, there is an element of management, there is an element of business understanding which is also a part of a data scientist job. Okay, so you have to talk to different people, you have to understand things. You might talk to people who are not good in technically. Okay, so you might have to understand in layman's language, you might have to understand things in business language. But then at the end of the day, you have to solve it using technical solutions, so you have to convert that business problem into a technical problem. So that is one part of the job. Second part of the job is, obviously, since you are a data scientist, so you have to deal with data. So you are going to work with a lot of data, and a data by data could be many types. It could be in the form of text, it could be in the form of number, it could be Excel sheet, it could be databases, many things. Okay, and lastly, you might want to analyze the data, you might come up with a lot of insights about the data, but at the end of the day, you have to build something, you have to build certain solution, and solution is always a software. At the end of the day, whatever insight you build, it doesn't matter unless you are able to convert that solution into some piece of software. So there comes a piece of software engineering aspect also. So a data scientist typically will be good in all these three things. One, the data scientist will be good with business. Second, the data scientist will be good with dealing with data. And third, the data scientist will be good with building software problems, software solutions. So some element of software engineering, some element of data analysis, and some element of business understanding. This is basically what a day-to-day life of a data scientist looks like. Okay. Now, this is basically, I typically always, whenever I try to explain to someone, I try to use this plot, and it's a very vague, you can say. I mean, like, it's not 100% correct. There could be many more things which I can include here, and again, it can vary, but this is like a very simplistic way of how I can represent to make you understand. Okay, so three subdomains: one is mathematics and statistics, another is business knowledge, and another is computer science. The marriage between all these three is what contributes towards what we call as a data scientist. Okay, now, why do we include computer science? You know that you have to, at the end of the day, you have to convert things into software. Why do you know business knowledge? Because you have to deal with business people, because they are the ones who are going to bring you the problem statements. Okay, so you have to deal with business people, so obviously business knowledge is important. And lastly, why mathematics and statistics is important, you will know, realize this later, that when we say data science core is always lying on mathematics and statistics. So it's not that we are trying to build algorithms, build data solutions. All of these are them are built by intuition or anything. No, it's not. It's all based on the fundamental principles of mathematics and statistics. Just to give you a very brief idea, think about something like that. Let's say if I want to build a software which can predict which can predict whether there is going to be an accident on a traffic signal or not. Okay, so what could be a simplest way of solving this problem? I mean, even you can think of that. Like, you might have studied in class 12 probability. So if you can ask someone that, can you provide me the data of all the persons who all the accidents which has taken place and how many people has crossed this particular traffic signal. So you can simply just do like, okay, in the last 1 year, maybe 10,000 people has crossed this particular signal, and there has been three accident. So there is a probability of 3 by 1000, so 0.003 probability of an accident happening. Now you can go into maybe conditional probability, and you can say that, okay, the accidents happens more in winter, so maybe conditional probability of an accident happening when it is winters, or condition of probability happening when there is a snow, or condition of probability happening when there is huge traffic. Okay, so accident happening when there is huge traffic. So just telling you an example, like a simple probabilistic approach can also try to solve this problem in a very simplistic way. This is becomes the base of all the fancy and complex algorithms also. So as a data scientist, you need to have all these three skills. Now you should not get intimidated by this. It does not mean that you need to be an expert in all of these things. Sometimes it does sound intimidating, like, okay, one person knowing computer science also, mathematics also, and business knowledge also could be too much. But what I'm trying to tell you here is, although you need to know all of these things, but you don't need to be an expert in all of this. You need to know the basics of all of these, and the once you know the basics of all of these, the marriage which we do between all these three, this is what makes you basically a unique person, or what we call usually data scientists are also referred as unicorns. Okay, so unicorns are basically which is rarely found. So it's actually, to be honest, if you ask any data scientist, it's actually quite easier to learn some part about multiple things rather than know everything about one thing. I mean, even you might realize this. Like, if you when you did your preparation for your engineering, you might have studied chemistry, mathematics, and physics. So learning some physics, some chemistry, some mathematics is easier compared to becoming an expert in mathematics or something like that. So if you try to master all these three domains, not completely master, but maybe some part of it, maybe you might be an expert, better expert at mathematics, slightly less in business, slightly less in computer science, or vice versa. You are well to do, and then later on, while doing your job, you can obviously learn more things about it. Okay, perfect. Now, we'll try to look into a little bit more in details about the same things which we studied. So here we talk very broadly in terms of computer science and mathematics and all. Now we'll try to go into a little bit deep dive into what exactly does contribute towards it. Okay, so few things. One thing which we have, if you have noticed my last slide, we have discussed that we need to obviously have some software engineering, because software engineering is definitely required. Okay, so you need to know programming. Okay, now you can do programming in any language you want. There is no restrictions as such. You can do programming in C++, or you can do in Scala, R, Python, Java, anything. But there is a preference towards Python, at least in the last 3-4 years. Like, if I go 5 years back, R and Python both were competing with each other. So maybe I would say, like, 5 years back, 60% of the data scientists were working using Python, maybe 30% were using R, and maybe the rest of them were using Java and C++. Okay, but if I compare right now, almost 70 to 80% of the people are using Python. So it has completely dominated this world. Okay, so I'm not saying that the Python is the best language or anything. I mean, at max I can say, like, there are many things which we can't do in Python, in fact. Okay, so obviously every programming language is designed for something. But because of the popularity of Python in this programming world, in this machine learning and data science world, if you want to start off, I would always recommend that you start with Python. Okay, so again, repeating that, it does not mean that I'm endorsing Python. It does not mean that I'm saying that you can't do data science in R. You can definitely do. You can definitely do data science in Java also, but it will be slightly difficult for you to start off with. So if I would recommend, if you are starting off, you start off with Python. Okay, that's one thing. Next is, you require several tools. Now, what are tools? Tools are basically something which people have built for you. So if you want, you can build those whole tool completely yourself also. So it's like, if you have done if you have done any programming, you might be aware of these things. What we call as, in Java, you might call this as packages. In some languages, we call it as libraries, which is basically something like this. So let's say if you want to calculate the mean of a maybe an array. So let's say you have something like 1, 3, 7, 4. And if I ask you to calculate the mean of this, you can always calculate. You can say, okay, 1 plus 3 plus 7 plus 10, whatever it's 17 or 8, no, whatever it is, and divide by 4, 5, and you can come up with something 3.43, whatever it is. Okay, so you can always do that calculation. Okay, similarly, you have calculators also. So in calculators, there are two options for you. One option is you can enter 1 plus 2 plus this and then divide. Or the other option in the calculator, when you use scientific calculator, there is a ready-made button. There is a ready-made button for mean or standard deviation. Okay. So either you can use that ready-made button of standard deviation, or you can do it yourself, calculate mean, and then you do that x minus x bar whole square summation divide by n under root and all those things. Okay. So the idea which I'm trying to tell you here is, when you use data science, there will be a lot of things which you can do it yourself also, but a lot of people have already built that for you. So you should utilize that, and those are what we call as tools or libraries. Okay. So in every infrastructure, every programming world, those will be there. Like if I talk about Python, something like NLP, NumPy, NLTK, Spacey, these are some of the popular libraries. Similarly, there are in Java we have Core NLP, Stanford NLP. Okay, there is Rapid Miner, which is UI based tool. So depending on where you are working on, you can always make use of these tools, and there's something which I would again always recommend for you to use. Now it might sound again a little bit something out of the box for you right now, that what exactly these are. Do know, you should not worry about this. Once you start learning about it, you will definitely understand what I'm talking about here. But the idea what I'm trying to tell you is, don't be averse to using tools. Sometimes it happens, like when we come from technology background, when we come from engineering background, we have this mindset of building everything by ourselves. But then there is a saying that you don't need to reinvent the wheel, right? If the wheel has already been invented, so you make use of the wheel and try to build a car. Even the car has been built, so you try to make use of the car and try to build something advanced than that. Okay, so you don't need to work on the basic thing which has already been done. Okay. So that's another thing which is a necessary skill. Next is, obviously, as I talked about, you need to know mathematics, and by mathematics you don't need to be Ramanujan. Okay. What I mean is, you need to know fundamentals of probability, you need to know a little bit of calculus, standard. If you have done normal standard calculus in your class 12th, you're good to go. Maybe slightly a little bit more on, if you want to get better at it, maybe learn a little bit more about vector calculus. Okay. And then slightly about statistics. Again, statistics, I'm not trying to tell you that you need to be again an expert in statistics and know everything, but maybe something like basic hypothesis testing, mean, standard deviation, p test, t test. If you know these things, and even if you don't, you can always read about it. Maybe a few days, if you invest in a good statistics book, you can always catch up to that. Okay. So but the idea I'm trying to tell you is, this is something which you will have to do. So if you think that I have no interest whatsoever in statistics, mathematics is something which bothers me, mathematics is something which makes me run for my life, then data science is probably not the right career for you. But if you don't know, if you think that you're not an expert in mathematics, if you think you're not an expert in programming, but you have the interest to learn, then data science is always the right field for you. Okay. So the only thing I'm trying to tell you is, this is a part of it. You don't need to know everything, but you should have the interest to learn these things. Okay. Apart from mathematics, then we comes to something what we call as machine learning, which is basically the core of the data science, which is the learning algorithms. When I was talking about making a coffee, I said that we will try to build a machine, an algorithm which basically which can make coffee by using data. Then how does it learn? Okay, so that learning process happens what we call as algorithms. Now algorithms again is basically a set of certain rules or certain methodology by which you typically learn. So think of this like this, like when you learn driving. Okay, so when you learn driving, what happens? Remember your childhood days when you learned something like riding a bicycle. Now it was not programmed to you by birth. I mean, nobody you were not programmed to ride a bicycle by birth. And you might have noticed, like when you started riding a bicycle, you have fallen a lot of times also. So that was a very typical example of an data driven algorithm. What was happening is, first thing which you did is, your mind was noticing a lot of people riding a bicycle. Like a lot of people, you saw that people, when they ride bicycles, they don't hit on a pole, or when they see a wall, they stop or they turn. So there's something like a data which is being fed into your mind. When you started riding your bicycle, you might have started, and then when your bicycle was falling towards the left, instead of turning your handle towards left, you turned right. What happened is, you fell off. That was again another data point created for you, and then your mind started learning, no, this is the wrong way of riding a bicycle. If my cycle is falling towards left, I should turn my handle towards left. That way I will maintain balance. And then vice versa happened, and then again you learn. So sometimes you learn what by positive examples that you whether you did not fall, and sometimes you learn by negative example where you did fall. Sometimes you might have hit someone also, like maybe you saw someone and then you just hit him, and then you realized, okay, no, if there is someone in front of my cycle, I should press brake. Okay, so this is a typical example how an algorithm is working. So in your mind there are thousands, in fact millions of algorithms already running. Okay, and that is exactly what we try to replicate here in machine learning also. We try to teach these methodologies of learning to the machine itself. And then there could be multiple types of machine learning algorithms depending on the type of application. Okay, now there could be many applications. I will not go into detailed about each of them, but I'll give you a very brief introduction about at least the first three of them. Okay, so this is very critical, and just to give you a sneak peek into like what kind of problems you solve. So I will just discuss these first three problems, which is basically classification, clustering, and regression. Okay, now classification is whenever we try to solve a problem of classifying something into multiple buckets. Either it could be two buckets or three buckets or whatever it is. Okay, so an example of classification could be, let's say in this session we have a lot of people joining, right? Now maybe I can see your names, but I don't see your CGPA, okay, or your SGPA, or maybe your gender. So let's say I try to bucket all of you guys between males and females, like who are males, or maybe males, females, transgenders. Okay, so if I try to solve this classification problem, taking certain data out of you, okay, not exactly the gender part. So except the gender
Excuse me,
part,
sir.
yeah, please.
Your screen has freezed. I
Oh,
mean,
is that
your
so?
video also. Yes, sir.
1 second.
I mean, the video
But you are
also.
able to hear my voice, right?
Yeah, your voice is clear.
Okay. So let me
Screen
turn
has
off
freezed.
the video first. Mm, do you see the screen changing now?
Yeah, I can see the screen changing, but the video is freeze, sir.
Okay, fine. I've just turned off the video. Maybe something is wrong with the network.
Okay, okay.
Okay. Okay. Yeah. So we were talking about the different types of problem statements. So we were talking about classification. So as I said, like one example of classification could be like classifying you guys between males, females, and transgenders. Now, when we try to do that, let's say I have the data of you, maybe some data about you in terms of your maybe your hairstyle, length of your hair, data about your clothing, the color of your clothing, or data about your walking style. So things like that, and an algorithm trying to learn from these data points that whether you are a male or female. Or so this, whenever we try to solve this kind of problem, they where we try to bucket things into multiple classes. That is what we call as a classification problem. Okay, now another type of problem which we try to solve is in machine learning is what we call as clustering problem. Now clustering problem is basically where we try to do some sort of clustering. So clustering could be like where we don't know what to, it's similar to classification, but it is different in a way that in classification we exactly know what buckets to fill. Like in our case, earlier case, we knew that we want to classify them into male versus female versus transgenders. But what if I say that I give you a data point? Let's say I give you a certain set of apples. Okay, I give you a bucket of apples, or I give you a bucket where there are multiple fruits. Okay, I don't tell you anything. But what we typically do, you'll typically do is when you take that bucket and when you're putting it in fridge, you might do certain organizations. Okay, and that is human nature. How that organization is, I didn't tell you. But what you will do is maybe either you will do something like you will put apples at certain location, then oranges, and then maybe mangoes. Okay, or some people might do it differently. Some people will say that bigger fruit, they will put the bigger fruits in one at one location, and then the smaller the mid-sized fruits at another location, and then the smaller fruits at the another location. Or someone will do something like based on the colors, like maybe red ones and in one direction at one place, green ones on another place, and things like that. What I'm trying to tell you is it is again a type of classification problem, but the buckets are not defined here. So whenever the buckets are not defined, we what we do actually is not classification, but rather than classification we call it as a clustering. So these are also one kind of problem which we solve extensively in data science. And again, I'm giving you very day-to-day life examples. It doesn't mean that we actually solve these day-to-day examples. We actually solve some other problems, okay? But you get an idea. You, to make you understand, you can understand by these day-to-day problems, okay? And another type of problem is what we solve as regression. Again, it is a very popular type of problem which we solve in data science. Regression is whenever we try to not predict class, not predict cluster, but we rather try to predict the actual number of something. Okay, so an actual number could be like, let's say I want to predict the temperature of Mumbai today. Okay, now how do I predict temperature of Mumbai today? Based on what was the temperature of Mumbai yesterday and day before yesterday and so on, so on. So can I predict? So whenever we want to solve this kind of problem, this is what we call as regression. So like I mean, a very simplistic idea could be, okay, if yesterday was 24-degree, then maybe day before yesterday was 23, and day before yesterday, before that day was 22. So probably today will be 25. Okay, so a very simplistic example I'm giving you. It doesn't work like that. But based on the past historical data, I'm trying to predict the actual value, not class, not cluster, but the actual value. Whenever we try to predict actual value, we call it as a regression problem. Other could be predicting income, predicting anything which is continuous in nature. Okay, and then apart from these three basic problems, there are many different type of other problems also. Like we have anomaly detection. Anomaly detection could example could be like whenever we try to find out something odd one out. Like you might have solved those problems in your quizzes, right? Where we try to find the odd one out. That is basically an anomaly detection. Okay, like you have multiple things, but there is something which is different than the others. Okay, an example and real world application of this could be detecting hacking, like whether your network is hacked or not. Okay, so what happens is there are multiple users logged on into a network, but we try to identify if there is some unusual activities happening. Okay, and that unusual activities is different from the usual pattern. So that will not be very obvious. Like out of million, there will be maybe one or two. So those are that type of problems are called as anomaly detection. There is recommender system. Recommender system is something like you do the same thing using when you use your e-commerce website. Like let's say you're ordering from Flipkart, you might have noticed that if you order a red pant, then suddenly a red shirt also appears in your recommendation. Or if you're searching for phones, suddenly data cables also appears from your. So there's something a type of problem which is called as recommender engine. Okay, and then there are many other problems. Again, we can't go into details of each of them. Okay, and the last thing which is most important to a data scientist is what we call as deployment. And deployment is basically after building the algorithm, after doing the programming, analyzing the data, at the end of the day, you need to deploy that software somewhere. And for the deployment part, this is there are again multiple tools available. I'll not speak a lot about each of these tools today, but these are also an
Excuse me,
important.
sir.
Yeah.
Hello. Sir, I
Yes.
think the
Please go
slide
ahead.
has freezed, sir. Sir, the
No,
slide
no, the
has
slide
freezed.
hasn't
I mean,
freeze.
it is.
No, slide hasn't freeze. I haven't changed it yet.
Okay, you have not changed it. Sorry.
Okay.
Okay,
Yeah.
you are on skill set only.
Yeah.
Okay,
Yeah.
okay.
Perfect.
Sorry.
Okay. So on the deployment side, there are multiple tools. Like there could be, I mean, some knowledge of cloud services, some knowledge of big data, Hadoop. Again, these might sound a little bit off topic for you, but I just wanted to give you an introduction to this. This is something which you might learn later on, so you don't need to learn it from the start. Okay, but this is also a part of the data scientist job. Okay. Now, as we are talking about, let's just try to get a little bit more details in terms of the applications which we're talking about. So, here you can see multiple industries, how in multiple industries data science is being utilized. So, I mean, like in today's world, almost every industry utilizes data science. So, whether we talk about e-commerce, whether we talk about manufacturing or transport or finance or in any sector, it does. For an example, if I talk about e-commerce, I've just told you like a recommender engine is one of the very simplest thing which you can notice about an e-commerce industry utilizing data science. Okay. Similarly, you again, let me give you an example. If you have used Amazon or Flipkart, you might have noticed that on Flipkarts, when you see the reviews, within the reviews, those reviews are bucketed based on certain types. Like let's say you talk about headphones. So in a headphone, if you look into the reviews of headphone, you might be able to click on based on sound quality. That will give you the reviews only based on sound quality or based on comfort, based on color, based on design, and so on, so on, so on. All right. So how are those being generated? Those are being generated by analyzing the data and doing something which we call as text processing, processing the text. Okay. So just giving you an example, like how data science is utilized in e-commerce industry. Okay. Similarly, in manufacturing industry, also data science is extensively utilized. In fact, this is one of the industries which had adapted data science quite from the very beginning. Okay. So in manufacturing, again, just to give you an example, a very simplistic example could be like detecting faulty products. So think about a like maybe a bulb manufacturing company. Now, when you manufacturing company manufactures bulbs, they might not want to sell faulty bulbs to the consumers because that might lead to like bad reputation of the company. So, but they can't also test each bulb manually also, like maybe plugging and all. So that can be done using data science. Like imagine like there is a conveyor belt where all the bulbs are going on, and then there is a camera put on top of it, and the camera clicks an image of that bulb and analyzes, so what we call using computer vision, and analyzes and finds out whether the filament is broken or not. Okay. And if that can find out, it can just simply just separate that bulb from the rest of the lot. So it's a very automated way of separating, and this happens a lot in manufacturing industry. So just giving you another example in manufacturing. Banking industry, again, banking industry, there are extensive examples like fraud detection is obviously one, like detecting frauds. Risk modeling could be something like if you own a credit card, they give you certain limits, like you don't like everybody cannot have the same limits on credit card. Someone earning 3 lakhs would be having better limits, while someone earning maybe 30,000 will have lower limits. So how those limits are calculated, how much to give, how much not to give, EMIs, interest rate, and all those are again a part of analytics, what we call as risk modeling. Okay. Healthcare industry, you have recently noticed coronavirus. We have gone through this for the last 3 years, and data science again. Like if you talk about even vaccines, the discovery of vaccine itself is basically a data science problem and data science solution. So I'm not really sure about like how much you are aware about this, but the vaccines are manufactured using something what we call as two techniques. Like we have the one is the inactive virus, another is mRNA technique. So RNA is again going little bit on your biology section, but RNA is basically sequence. You might have in fact this I believe this was a part of your 10th class biology where we know that DNA is basically a sequence of multiple types of ingredients, right? And those sequence are basically being tried. We try to match those sequences with the sequence of the DNA in the virus, and then we try to replicate them so that we can counter them. So I'm just trying to tell you like how data science can be utilized in medicine industry also. Okay. And then there are many other applications like x-ray analysis, like taking an image of your x-ray and identifying what is the problem with your chest. Okay. And so on. Transport industry, I've just talked about self-driving car. There could be monitoring system, alerts, safety alert system, like something like there was this show in India which started recently called Shark Tank India, and I remember there was one of the participants who had presented a smart helmet concept, like a helmet which can predict whether you are going to have an accident or not. And if the helmet predicts if you are going to have an accident, it will alert maybe the neighborhood or hospitals or something like that. So just telling you, like, there are so many ways where data science could be utilized. Okay. Okay, so these are certain applications. Again, these are not the only applications. There could be many. In fact, as I said, in today's world, any industry you touch, there will be some part which is where data science is being utilized, and that is why there is this huge number of jobs in this particular industry. Okay. Perfect. Now, lastly, before we proceed to our hands-on section, I'd just like to discuss a little bit about the whole life cycle. So I've talked a lot about data science, what it does, what kind of application it does, but I'll just try to combine everything and just try to tell you how exactly this whole process of data science, maybe a particular whole data science life cycle works. Okay. So a complete solution would look like something similar to this, where you might see this top box. The top box is where we see the data sets. So obviously, when you're dealing with when you're solving a data science problem, you're obviously going to deal with data sets. Okay. So and when we say data sets means data. So the data could be present to you in the form of Excel. It could be present to you in the form of maybe raw text, or it could be form of to present to you in the form of maybe databases could itself could be of multiple types. You can have SQL, NoSQL, you can have RDBMS system, Redshift, and then there are so many. Okay, I'm just trying to give you a sneak peek into what kind of data sets you might be dealing with. Okay, now once you have the data set, so the first important part is data retrieval. Data retrieval is basically how to fetch the data, okay, from the data source. Now if the data is available to you in the form of an Excel sheet, it's very easy, you just import that data somewhere, okay, it's easy. But it's not always that simple, okay. Sometimes the data is not available to us like that. Sometimes the data is available to us in a database, so there you'll need to build a data retrieval system which can fetch the data from the database. Sometimes the data might be available to you in the form of an API where you need to send a request and then the API is going to send you back some response. So I mean, like, depending on what type of data set you are dealing with, you need to build a data retrieval system, okay. So the data retrieval system is the first component of a data science solution. Second is what we call as a data preparation, okay. And data preparation is basically, even if you have the data, it doesn't mean that you can directly feed the data into an algorithm. The data has to be prepared to be ready for that algorithm, because an algorithm will be able to take the data only on a particular format. So you need to process the data. Sometimes the data will be very dirty also, like the data might be having missing values, the data might be having like bad data, bad examples. So you might need to clean the data. Sometimes you might need to process and transform the data also. We call this process as ETL, extract, transform, and load, okay. So anyways, not going into the detail of everything, every technical terms, but what I'm trying to tell you here is this data preparation stage is also very, very important. That is where your data will become ready to be fetched into your models, into your algorithms, okay. In fact, to be honest, 60% of the time of a data scientist goes into these two steps, which is basically dealing with fetching the data and building the right data, selecting the right data, making pre-processing the data. And this is the dirty work which you will always have to do. Although the core job of a data scientist is what we call it as a modeling. And that is where all the algorithms comes into picture. So if you recall our previous slide where we are talking about multiple algorithms types like classification, clustering, recommender engines, anomaly detection, regression, all these falls into this bucket of what we call as modeling, okay. And those algorithms are called as machine learning algorithms. There are many types of algorithms which I will give you the names of some of them, okay. But this is the core task. Now, after the modeling process, again, another important task is, okay, you have built a model which can maybe do a prediction. So let's say we are talking about building a model which can predict the prices of a house. Okay, so it can predict the price of a house and it tells that, okay, the price of this house is 1 million. Okay. Now, whether that prediction is correct or not needs to be evaluated. Like you, when you are given questions in your examination, you obviously always write answers. Okay? Whether you know it or not, you do write your answer. Okay, but whether those answers are right or not, it has to be evaluated by an invigilator. So that evaluation stage is what we call as model evaluation and tuning. That is, the invigilator will evaluate and tell you that, okay, maybe out of 100, 60% of your answers are correct, 40% of your answers are incorrect. So there would be two options. Either the invigilator will say, okay, 60% is pass, you are fine. Okay, let's move on to the next semester. Or the invigilator will tell you, okay, no, you have only corrected 30% of the answers. 30% is not how we can make you go to the next semester. So you will have to reappear in the same exam. So it will send you back to the same data and tell you learn again. Okay, so you learn again, you again give the exam, and then again your performance is evaluated. Until the time your performance is found to be satisfactory, you will be sent back into this. Okay, so this is what we call as model evaluation and fine tuning the model. Okay, now once you're satisfied that, okay, this model is predicting well, this is going to giving us a very good accuracy and all, then the last stage is basically converting this whole model into a piece of software which we call as deployment and monitoring. Okay, so that piece of software could be anything. It could be a GUI based solution, it could be a web-based solution, what we call as software as a service. It could be an API if you're giving it to a particular business. It could be maybe an Android application. It could be iOS application, anything. So whatever it is, all we are just clubbing this and writing it just one word, which is deployment and monitoring. Okay. So this is how a typical data science solutions will look like. Again, depending on the solution type, depending on the data type, it might vary. There could be many more boxes, or maybe some of the boxes will not be there. But I'm just trying to give you a general picture. Okay, perfect. Lastly, we have just give you again an examples of the different types of algorithms. If you recall, we have talked about classification. We have already discussed whenever you try to bucket things into multiple buckets, like duck versus not duck, it's called classification. whenever we try to bucket something, as we talked about fruits, like multiple clusters, so this would be clustering. And similarly, if we're trying to predict something continuous in nature, like we had in this particular case, we have the data of prices of a house till 2014, and now you want to predict the price of the house in 2015. This is called as a regression problem. Okay. Okay. Lastly, this slide is basically just trying to show you some of the important or popular libraries. Remember, in the beginning of our session, we talked about that there are many tools and libraries already being built for you, and we can always make use of them. So these are some of the tools and libraries which are available to you, and you can always use. For an example, like this matplotlib, which you see, this is a tools which helps us in plotting very fancy graphs. So plotting different fancy graphs, you don't need to write the whole code of generating a graph. You can just write one line and it will be able you will be able to do that. Similarly, if you are dealing with Excel data sets where the data is a structured format, we can make use of this libraries called as pandas. It helps us working with that easier. In fact, I'm going to work with that in our session today itself. Okay. And similarly, there are many other libraries which you can take help of. Okay. Perfect. So that's all the theory which I wanted to discuss. Okay. If you have any questions, I'm going to answer you during the end of the sessions. Okay. But before we do that, what we will do is we are going to do a little bit of hands-on. Okay. And for the hands-on, we are going to just use our browser, which is Chrome. Okay. So let's do that. And as I had said earlier also that you can always code work along with me. So when I say work along with me, if you have a computer available, please work along with me as I'm just explaining. Okay, so I am going to give you a slight idea. I am going to give you an introduction how to start. So what you will need to do is you will need to open. You will in Google. You will need to type collab. Okay, when you type collab, you will use this link collab.research.google.com. I'm going to copy this also. So I'm going to paste this in the comment section. Let's see. Okay, I've shared the link also. So you can just type it in Google also, you will find it. But if you are not, you can just use this link. Okay. Now, when you do that, okay, when I do this, something like this screen will appear with to you. Okay, so you'll see this screen. Now you might not see this because if you're opening it for the first time, you will see this empty. So these are some of the collab notebooks which I had already opened or already created, but for you it will be like completely new. So you don't need to worry. What you will need to do is you'll need click on this new notebook. Okay. It can also ask you to sign in using Google. So I'm already signed in, so it did not ask me. But if you are not, it will ask you. So you can just enter your normal Google login ID and password, and then you can use this. Okay. So you'll click on this new notebook, and once you click on this new notebook, a screen like this will appear. So I want all of you to go to this stage and open this collab notebook. I'm going to wait for a couple of minutes for all of you to do this. Okay. And then we will start writing some small codes. Okay. So we'll not go into like very technical. We'll not go too much in detail. And I'm going to show you it's quite easy actually to start off with. So that's the whole idea. The idea is I cannot teach you programming in this 30-45 minutes, but the idea is to show you it's quite easy to start off with, and if you are interested you can always do that on your by yourself. You don't need help of anyone. Okay. So I want all of you to do it till this step. Okay. I'm going to wait for a couple of minutes. In case someone faces any issues or has any questions related to that, you can always type your questions in the chat. So all of you should be able to do that. And once you open, in fact, just to show you, I can just do that again. So what you will do is, again repeating, you will just type this collab.research.google.com in your browser, and you will see this. You will click on this new notebook, and this will appear. Okay. You will have to click on this connect button. So you will have to click on this connect button. Okay. So initially you will see connect. Now once you click on this, it will become green. So now once you see this green tick, you are ready to go. Okay. If you want, you can give a name to your notebook here. Okay. By default, it will be something untitled one, untitled two, something like that. So if you want, you can give a name to this. So I can give something like this. Whatever you want. The name is totally on you. Okay. So I'll wait for another minute. So I see a lot of you are already able to do it. Perfect. Okay. So now what this collab is, basically collab is nothing like, if you have done programming, you might know that you need an editor to write your programs. Okay. So for every programming languages, there are certain editors. Like you can use PyCharm for Python. You can use Visual Studio Code. You can use Visual Studio if you're working with C Sharp. You typically use JetBrains if you're using Java, or maybe even Visual Studio itself if you're coding in Java, and so on. Android Studio if you're writing code in for Android, and so on. So, okay. Similarly, Colab is basically a Google hosted platform to write codes. So if you when you start learning Python, you know that there is something what we call as Jupyter notebooks there, and notebooks are a nice way of, it's a type of editor, but it's an interactive editor. Interactive editor means where you can interact with your program side by side also. So it's like uh, again making the, I'm assuming here that you know the difference between different type of programming languages. Typically programming languages are classified into two buckets. One is what we call as object oriented program, another one is what we call as interpreter based, like them. Or typically what we call as like compiler based languages and interpreter based languages. So Python is basically an interpreter based languages where we don't need to compile the whole program, we can directly execute. Okay. So this notebook is Google hosted. It has already has Python installed in background. You just need to run your code and we can interact with this. Okay. And that is why we have selected this, because for this learning session, I cannot expect you to come everything installed and all those. So that is why we are doing it here. But it doesn't mean that the code which we write will always have to be written in Colab only. You can write it in any editor you want, any editor of your choice. Okay. Perfect. So let's start with some very basic things what we do in programming languages. Okay. So I'm going to just introduce you to some very basic things which you might, some of you, if you're already into this world of programming, you might find it a little bit boring, but don't worry about it. Just hold on with me for a few minutes and then you will find it interesting also. Okay. So first thing which you will learn is how to define a variable. So in programming language, we typically define variable. Variable is something where which we can assign a certain value to it. Okay. Now, again, depending on the type of programming languages, a variables defining process varies. Okay, so if you're working with Java, first we will have to define that variable, that this is the variable, and we'll have to tell what is the type of that variable. That is, what are we going to store in that? Whether we are going to store a string on that, whether we are going to store an integer on that, whether we are going to store a float number in that. We have to tell that initially. In Python, we don't have to do that. In Python, we can directly define the variable and store that also. Okay. So we can simply just write a equals to 2 in Python. Now that is why Python is called as a dynamically typed language. Okay. Those languages like Java, C, C++, where we have to define the type initially, those are called as statistically typed languages, where the type becomes static. Okay. So type becomes static. Okay. So those are statically typed languages. This is dynamically typed language. Okay. Now here when we define a equals to 2, Python itself recognizes that this is a variable which has type integer because we have stored integer. If we define this a equals to 2.3, it identifies that this is a variable which has type float. Okay, so we don't need to define them. We just directly assign values to them. Okay. Okay. Now to run this, you will press either Control Enter or Shift Enter. To run this, you will either press, I have pressed shift enter. Whenever you press shift enter, it executes this and also goes to a next cell. If you press control enter, it will simply just execute this, but it will not go to the next cell. Okay. Or you can, to run this, you can just click on this play button also. Okay. So it's your choice, but I'll typically always prefer to use shift enter. So when I do shift enter, now I'm assuming that this code has run. This is a code actually. This one line which we have written, it is actually a piece of code. Now, what I have done in this piece of code is I have assigned the value 2.3 to this variable. So this a, if I type a and I simply just run this, it should display the value. And you will see that it displays that it has a value of 2.3. That is how we define variables. Okay, perfect. Now, once we have done that, let's go do a little bit of more thing. So it's just like numbers, I can assign certain string to it also. So let's say I assign something like an apple. So this is what we call as a equals to apple. Now, if I check a, it simply says it has apple. Okay. Now, what we can also do is we can also take certain part of this apple. So what if I don't want this whole apple? I want only a double p. We can very easily do that, and we can write, or in fact, let's name it something like an x. Okay, so that you don't get confused between apples a and this a. So x is apple now. Now, what I can do is I can write x and these square braces, and within these square braces, I can write 0 colon 3. Okay. By the way, let me zoom this just in case if it is not visible to everyone. Okay. Now, when I write x colon 0, x square braces 0 colon 3, what it means is this x variable, which has apple, we are trying to select a sub part of this, sub part of this string. And what is the sub part? Whenever a string has multiple things, it basically tries to give certain indexes to this. So indexes are basically like a ID. So you can think of it like they are all in a queue, and this one is given an ID 0. This is ID 1, 2, 3, 4. So A is basically 0, P is 1, this P is 2, this L is 3, and this is 4. Okay. So when you do 0 colon 3, it means it will start off with 2 0 and end at 3. Now the default syntax in Python is this is included, this is excluded. So whenever we'll write 0 colon 3, it means 0, 1, and 2, not 3. Okay. This is the default syntax. Okay. So if we do that, so ideally it should include 0, 1, and 2. So it should include a double p. Let's see whether it is giving us a double p or not. So you can see when we write x 0 colon 3, it gives us a double p. Okay. So that is how we select substrings. So we can do multiple things with this. Like we can do something, we can define another variable called as y, and we can say, let's say mango. Okay. And now we have apple also, we have mango also. What if I want to combine this a double p and this geo? So what if I want to form another string called as app go? Okay. So I can do that by what? By writing something like this, x 0 colon 3. So x 0 colon 3 becomes app, and then I'm going to add this to geo. So to add this, I'm going to add this plus. And how can I define geo? I can define geo by using y. So I can write y square braces. Now geo is starting from which place? Starting from 0, 1, 2, 3. So starting from 3 and ending at colon. And if I write colon anything, so it means till end. Okay. If you don't need to provide the index here. Or if you want, you can write -2, -1, whatever. But I'll just keep it as it is. Okay. So when you write colon and nothing, that means till the end. So let's see whether it gives us app go or not. Yes, it does. Okay, so this is what we call as string manipulation. Now again, think of this scenario as working with the reviews within a Flipkart. Again, it's a very simplest. I mean, like you cannot directly just do it like this, but you can think of it as like the string processing, like the Flipkart's reviews which are there. Let's say you want to bucket those reviews between positive reviews versus negative reviews. So you can do a very simple thing like trying to find words which relates to good. So maybe trying to identify words like maybe a word like rubbish, it's bad. A word like excellent, it's related to positive review. A word like good sound quality related to a positive review. Word like broken, bad, negative reviews. So what you will need to do, you will need to do some string manipulation like this, what we are doing here also, you know. So just trying to give you that example. Okay, so this is what we call as strings. Now so these are all data types, like I just introduced, like string, numbers, float, strings. These are all data types. Okay. Another type of data type which is popular in Python is what we call as list. Okay. Again, it is basically a type of array. So every programming language will have some different forms of arrays. Okay. So this is one type of array. In Python, we typically have three types of what we call as arrays. So by the way, when you write hash before anything, it becomes a comment in Python. Okay. So we have three types of arrays in Python. One is called as list, one is called as tuple, and then sequence. So you can use any of them. All of them has different meaning to them. All of them has their different properties. Okay. Basically, they differ based on mutability versus immutability, but I'll not go into those concepts today. But let's just look at a list. If you want to write a list, you'll use these square braces, and you'll simply separate the members of these list by comma. So I can write 2 comma 3 comma 4 comma 5 comma 7. Okay, so this x becomes a list. As simple as that. Nothing more, nothing fancy about it. Okay, so now you can see this is like this. Now if I want to access this, let's say if I want to access this 7. So what is this 7? Again, just like this string, we can access them by their index. So just like this string, it has index 0, 1, 2, 3, 4. So if I write x of 4, it will give us 7. So let's try to find that whether it is not. So if I write x of 4, it actually gives us 7. Okay. Similarly, if I want to identify 3, so I can write x of 1, because this is 0 and this is 1. So x of 1 should be 3. So x of 1, if I write, this gives us 3. Okay, so that's it. If I want to identify 4, 5, 7, so what I will do, just like the again, similarly like the string, I should write x of 3. So this is 0, 1, 2. So 2 starting from 2 till the end. So 2 colon, and this should give us 4, 5, 7. Okay, so this is how we define list in Python. Now, what I can also do is, in a list, I can actually store multiple types of data also. So like typically this doesn't happen with other programming languages, where in like especially if I talk about C++ or Java, if I have an array of something like a typical array of numbers will always have numbers only. It cannot have a string. But here I can have a combination also. So I can have something like 2, and then I can have a number like maybe C, and then I can have 7, and then I can have a list as a member of this also. So a list containing, let's say, apple, comma, banana. Okay. So this is also how I can define a list. So you can see there is a list. The member of this list is a number, a string, another number. Okay. So another number, and then the last member of this list is itself another list. Okay. So this can also use. So all these things are possible here. Okay. So now, if I want to identify, let's say C, if I want to identify C, so then I will need to do write what? X of 1. So if I write x of 1, x of 1 refers to C, as you can see. Similarly, what happens if I write? What happens if I write x of, let's say, 0, 1, 2, 3? So x of 3, what it will give? Let us check. And notice this, what happened. Okay, just see for a few seconds. So what happened is, you can see this is 0, this is 1, this is 2, this whole is 3. So this whole is the third member of this outer list. Okay, now if I want, let's say, what if I want only the apple? I don't want this whole list, I only want the apple. So what I can always do is, this x of 3 is this list. So let's say, what if I store this in y? So I can write y equals to x of 3. So then y should be this list, right? Now, if I want apple out of this, so I can always write y of 0. So y of 0 should be this apple. And you can see y of 0 is this apple. Okay. What I could have done is, instead of doing this in 2 steps, I could have done this in a single step itself. How I could have done that? I could have written x of x of 3, x of 3 is this whole list. So x of 3 is this whole list which we defined as y, and then this x of 3, this y, zeroth of y, zeroth of x of 3. So x of 3 of 0. So I can simply just write this. And if I do that again, I will just get apple here. So this is what we call as list indexing, list indexing, list slicing. Okay. So this is one. What if I wanted only this PLE? What if I want this P and L or PLE? So I could have done that also. So I can write x of 3 of 0 of 0, 1, 2. So 2 colon. If I do that, you'll see PLE. So directly from X, I can get this PLE. Okay, by writing this. Okay, perfect. This is called list indexing and list slicing. We have done that also. Now let us look at little bit about reading data. Okay, so we'll not go into multiple other concepts like looping and conditional. You can always do that later on. But I just want to show you how to use data set. You know? So just to what we will do is we'll just load a particular data set and we'll just do certain manipulations. And for that we are going to use a particular library. I'm going to show that library also to you. Okay. Now to load a particular data set, what you will need to do, you'll need to click here. So on the left top corner, you will see these three lines, three horizontal lines. You will click here. Once you click here, you will see this. Okay. Here you will see this section, file section. So you will click on this. Again repeating. Let me close this and again show you. You will click on these three lines on the left top corner. Once you click on this, on the bottom you will see this file section. So you will click on this file section. Okay. And here you will find an option which is called as upload. Okay, so any data which you have, you can upload it here. Sorry. So I'm going to click on this. Okay, and I'm going to upload a data, and that data is okay. So we are going to upload this data. Now, after this session is over, I am going to share this data with all of you. Okay, so I'm going to share it with the host. The host can share it with all of you. There's an open source data. You can always download it from Google also. So you can get that from the link also. But right now, let me just show you how to do that. So I have just clicked on this. Okay, and this data is uploaded. Okay, so you'll see this. In fact, since you are coding along with me, let me give you that data set. So you can always download this data from this link. Okay. So this is the data set. Let me share this link with you. Okay. So you just need to go here in Kaggle and just download this data set. Okay, battles data set. So you'll just right click on this. You just click on this and you will just download. Here you have the option to download. Okay. It might ask you to log in. If you have already logged in, you can log in using Google and you can able to download. Okay. So just like I have the data, you can also have. Okay. If you are not able to do it right now, it's okay, but I would prefer that you do that. So I've shared that link. Just click on that link, click on the download section, and just log in using Google, and you should be able to have that data. Once you have this, you need to upload this data using this button called as upload. And once you have uploaded, this data will appear here. Okay. Now we are going to use this data. We are going to see what this data contains. Okay. So just to show you what this data is, let me show you that. So this is the data. Okay. So some of you might have watched, there was a series called as Game of Thrones. Okay. So this is the data of Game of Thrones, and someone has done some analytics on that. Okay. So what it contains is, it contains the list of all the battles which has happened over the course of 7 seasons. Okay. And for all those battles, it is like the year. We have the data related to the battle number. Who was the attacker in the battle? So Baby Joffrey attacked Robb Stark. So this was attacker one. So it has this data, and then the idea is basically who win that battle, right? Who has, like, whether the attacker win the battle or the defender win the battle. Okay, so you can think of it as a data science problem where you want to predict this. Like, what if you can predict this? who is going to win the battle based on other things, based on who was the attacker, who was the defender, what was the year. And then there are other things like attack, the army size of the attacker, the army size of the defender, and so on, so on. Okay, so there are so many things here, and also the location where it happened and so on. Okay, perfect. So this is basically the data. I'm just trying to give you an introduction into how, what kind of data usually there is, and how does a data looks like, and how can we upload it and start analyzing. Okay, we are not going to do complete analysis, but we are just going to show you how to start analyzing. So to start the analysis of this data, we are going to use a particular library today. Okay, and that library is called as pandas. Okay, there are many libraries which you will be using over the course of your data science learning. Some of the popular ones are pandas, scikit-learn. Okay, then there is numpy, scipy, NLTK, and so on, so on. There are many. I mean, like I can write thousands of them. Okay, but we are going to today use only this pandas, which is going to load the data set for us. Okay, so to use any libraries, you need to first install that library. Okay, now if you are working with any if you're working with your own editors, you will need to install this pandas library first if you want to use that. Okay, but in Google Colab, when you're working with Google Colab, it already comes with pre-installed with some of the libraries. Not all, like there are like hundreds of thousands of libraries available, but out of hundreds of thousands, the top 1,000 libraries will already be there in your Google Colab. So if you're using anything out of that, you will do have to install that. And to install anything, you need to write this code, which is called as exclamation mark, and then you will write pip install and whatever library you want to install. So if I want to install pandas, I will write this. But since it comes directly installed, so if I run this, it will tell me that requirement is already satisfied. So what I'm going to tell you here is, even if it was not installed, we could have just run this code and we would be able to install this. Just one line, pip install pandas, it will install. But since it's already there, we don't need to do this. Okay, perfect. Now to use this library pandas, first we need to do is we need to import this library. So I will need to write something like this: import pandas. Okay, so I will write import pandas, and I will execute. And now this pandas library is loaded. Okay, now we are ready to use this library to load the data. So we will see now, to use any library, what you will need to, like, how do you know that what is exactly the code used to that? So what you will do is you will Google. So you can simply always write pandas in Google, and let's say what we want to do here is we want to read this file, which is what type of file? CSV file. So let us search. I'm trying. I can write the code. The code is very simple, but I'm telling you how to learn from Google. Okay. So Google search is itself is a very necessary trick here. So we will write what we want to do. We want to use pandas, and we want to read a CSV file. So you can always type read a CSV file from pandas in Python. You can always type this. So let's type and see what results come. So you can see there's this. Let's go to the first link, and it tells us that you do import pandas, and then you do write this code pd.readcsv this. Okay, so we will just copy. Okay, so I'm just telling you how we can do something with a Google. So we will write import pandas as pd, and then we will do write data, or we can name it whatever we want. So let's say go to data equals to pd dot read CSV. Okay. Now, why I'm writing PD here? It's not necessary. Even if it was pandas, it's fine. So it's just what we call as alias in, right? Sometimes the name of the library itself is very large. So rather than writing the whole pandas, we have told that from now on, I'm going to call pandas as PD. So from later on, wherever I need to write pandas, I'll simply write PD. Okay. So I've written PD dot read CSV, and here you need to provide the path of the data. As you can see here, they're providing the path of the data. Okay, so where is the path of the data sets here? Our data is available here. So to know the path of this, what you will need to do is you'll click here and you click on this copy path. Okay, so there is copy path. You'll just copy this and paste it. That's it. So let us paste this, and now you can see we are writing pd.read CSV, and then this is the path of the data. Okay, let us see whether we are able to read the data or not. We said that we will be able to, but let's see. So let's run this, and it tells us that This PD is not defined because we did not execute this. So we will run this first also and then run this. Now you can see it successfully ran. Okay. Now, how do we know that whether this data is loaded or not? So we can always check this variable. So let's just type this variable. So let's type GOT data and control enter. And now you can see the data which you saw in the Excel file, you can see that data is available here also. So this GOT variable, GOT data variable is now actually containing the data. And now you can see it has this column name, year, battle number, attacker, defender, and so on. So on. Okay. So this is a data which we have. Okay. So this step which you're seeing here is basically the data ingestion step I was talking about. Okay. So remember this, we were talking about data set, we were talking about data ingestion or data retrieval. Okay. Now this is a very simple way of doing data retrieval. All your data will not be present to you in this simple format. Sometimes the data will be present to you in more complex format. But this step where you loaded the data from a source, which is a CSV file, to your variable, to your model, is basically the data retrieval stage. Okay. Now, once we have done this data retrieval stage, next thing you remember what we were doing here is data processing or data preparation stage. The data preparation is where you define what you require out of this data, what you don't require out of this data. You clean the data if there is something, so there we will do all those things. Okay, so let's now play with this data a little bit. Let us now play with this data and look what are there in this data. Okay, so in this data, as you can see, there are so many columns. Okay, what if I want to know how many columns are there in this data? So that's where pandas comes into pictures, and it makes our job very, very easy. Okay, so in the next column, I'm going to do, I will write our data is in this variable called as GOT data. And if you type dot columns, if I type dot columns, it is going to give me all the columns of this particular data. Just do that, and you can see all of the columns are being printed here. Now someone will tell you, some of you might tell me that, okay, fine, you know that it's called dot columns. How do we know? Like, how do we know that we should write dot columns, not dot col, not dot col, or something else? So the answer is simply go to the documentation. Okay, so you go to pandas, just type on pandas, go to this. Okay, and then there will be a document. Go to Google, click on this documentation. Okay, and in this documentation everything is there. Download that documentation. So you don't need to memorize anything. All of these things are always available. You can always Google and remember. With time, you will always, anyways, memorize those simple things. Okay. So the usual things you will memorize with time. Okay. So now let me see whether you can see it has instructions related to install this. Let me just directly move on to that bits of the code. Select columns on D type. You click on this. Now you can see it gives you all these things like different functionalities. So if I want, I mean, I'm not just talking about that. Any functionality which we are going to talk about, all of these things are available in this documentation. So, anyways, what I'm trying to tell you is, even if you don't remember what to type, what not to type, you can always just Google. Okay, so just Google print all columns pandas, and then you can always search. So you can always see that, okay, the idea is df dot columns. Okay, and that's this will be here also we are doing df is basically what we call a data frame. Here we have named it as got data dot columns, and it gives us the column. Okay, now let's do a little bit of manipulation on these columns. What if I want to select only this column, that is the name of all the battles? Okay, so I want to select all the names of these battles. So what we can do is we can simply write got data of name. If I write this, it will reject all of the rest of the things in the data and only give us the this particular column. Okay, let's see whether it does or not. Let us see. So we will type got data and we will type simply name. Okay, and if you do that, you can see it's only contains, now it gives us the names of all the battles. Okay, similarly, what if I don't want the name? I want a list of all the attackers, all the people who has attacked. So the column name is attacker king. So I can always type something like this. So let's say I write GOT data of attacker king. Attacker king. Okay, and if I do this, now you can see it contains the name of all the attackers, all those people who have attacked. Okay, what you can see that there is this Joffrey versus Tommy Baratheon is being repeated. What if I want just the list of unique name of list? Okay, so only the list, not repeating, only the list of all the individuals. Okay, so we can do that also. How can we do that? We can write something like this. So we can write GOT data of attacker king, and then we can do is dot unique. Okay, if I do this dot unique, it will give us the unique list of all the attackers. Execute, and now you can see it gives us the unique list that in total there were only these four total attackers: Joffrey, Robb Stark, Euron Greyjoy, and Stannis Baratheon. So this is like, so I'm just trying to show you how what kind of manipulations which we can do with this data. Another thing which we can do here is we can also maybe combine two columns and make another column of ourselves. So let's say we have this column. You can see there is this column called as attacker commander, and then, or let's see this. We have attacker king and we have defender king. Let us say if I want to formulate another column which writes Joffrey versus Robb Stark. I call another column which writes Joffrey versus Robb Stark. Okay, it is not there present in this data, but we want to create it. So you can do that. How can we do that? We can do that like this. Let me show you. So we have this GOT data, and in this GOT data, let's say we call this as battle competitors. This is our name. We are giving this name battle competitors, and this battle competitors will be formulated by using those two columns. Okay, so I'll write some code which you don't need to be worried about here. Okay, it might seem a little bit something new to you, but it's fine. So I'll write something like this. Okay, now you might not know what exactly apply is, what lambda is, but some of you, if you're already into programming, you already know lambda functions and all. But the idea here is not to make you memorize this syntax, but just to tell you that this is possible. Okay, so don't get intimidated by this. So I'll write something like this, lambda, and then I'll write maybe row colon, and then I might write something like a row of attacker king plus versus space vs space and plus, sorry, plus row of defender king. Okay. And I might also do something like a string of this. So I'm assuming there might be this, some of them might not be strings. Let's see what happens. It gives us an error. Let's see what the error is. We have this. Mhm. So it says no columns, attacker king. So let's say we have attacker king. Okay. Sorry, it might look a little bit messy to you, but don't worry about it. The idea, as I said, the idea is simply to show you that it is possible. Okay. Perfect. Now, if I check GOT data dot columns, first let's just do that. you can see there is another column created here called as battle competitors. You can see, right? So what I've done, don't worry about this, like how this code was written and all. You can always search for it and you can always learn this. But I'm trying to tell you is what I've done here is we had these columns, and based on these columns I had created another columns for myself. So we had these columns, but we have created another columns for ourselves, which is basically called as battle competitor, which should be this versus this. Let's say whether we get what that or not. So you can see first we saw that there is another column added here. Okay. Now let us look at the data again. So let us write GOT data. Okay. And let us check. And now we have this data set. And within this data set, let us scroll to the right. And on the right hand side, you can see there is another column created by us, which is called as battle competitors. And it is writing Joffrey Baratheon versus Rob Stark. It is writing Rob Stark versus Joffrey Baratheon, and so on, so on, so on. So you saw what I did is we have manipulated the data and we have created something out of it, which was not there already. This is what I was talking about here as data preparation, where we can do some feature engineering. So these columns which you see, these are called as features. Features means these are the variables or features based on which we can make a prediction. What prediction here we can make? Maybe here we can make the prediction that is who is going to win the battle. So the inputs which we pass into the model, like the defender size, attacker size, king name, attacker king name, defender king name, these are the input. These are also called as features. All right. And what is the output? This attacker outcome. Let's say if this is the output, this is what we call in data science world, we call it as the prediction, or we call it as a prediction variable, or also as label. Okay. Now when we had certain features, either we could have made that predictions by using the available features, or sometimes we also need to create our own features. And this is something which is very popular. I mean, like it happens on a day-to-day basis that most of the data which you will be dealing with will not have all the features which you want, so you will have to create your own features. Okay. And that creation of the own feature is what is this data preparation stage. Okay. And that is very critical. It's an art, it comes with experience. Okay. And I just wanted to show you how we can do that, this creation of feature engineering. We also called it as feature engineering. So here also what we have done is we have created a new feature by ourselves using the existing feature sets. Okay. Okay, perfect. So that is all we are going to cover today. Okay, guys. Then we can take some questions today. Apart from this, you can always learn by yourself and take it from here. Okay, there are multiple resources available on internet. If you want, I can maybe later on share some links. You can also always connect with me over an email or LinkedIn. Whenever I get time, I'm definitely going to reply. For now on, I can just take certain questions if you have. Otherwise, we'll close the sessions. So if you have any questions, you can ask those questions. Okay. Otherwise, we can call it a day. All right, perfect. Again, I thank all of you guys for joining the session. You have been very patient. I understand that there might be a lot of things which could be new to you. So it might seem like there are so many things, but you should not worry about it. As I said earlier, with time, if you are interested in this, I think after this session, it had at least given you some idea about what data science is about and what kind of things you are going to do within this. So based on that, if you have interest, you can always go through it, you can always learn more about it. There like, don't worry too much about from where to learn. Search on Google, take any YouTube tutorial, and just go start. And the only way to learn is just doing practice. So start learning by yourself. Whatever they are teaching, try practicing yourself, and then you can always learn. All right. And apart from that, if you have any queries, whenever you want any guidance or help, you can always reach out to me. All right. Okay, perfect, guys. I think we can end the session today. See you sometime later. Okay, Venkatesh, you
Okay.
can take it over. Yeah.
Yeah, yeah, sir. Thank you, sir. That was a wonderful session, and the students really connected with you. And the last Google Collab one, that was also very, very nice. And everyone was in live, and everyone was connected with you. So just last vote of thanks I would like to give. I would like to thank Sajjad Hussain sir for taking out his time and conducting the session for our institute. And I would like to thank Dr. Pawan Kumar Mishra sir, faculty in charge of TCP, for giving us this platform to invite the speakers and make our students acquainted with the latest technologies in demand. And lastly, thanks to the overall coordinators of TCP, Anish Gupta, Ashish Kumar, and Shivam Gupta, for working hard to make this event a success. And guys, we have a hackathon on 26th and 27th February. If you remember, the posters have already been shared. The prizes are worth 8 lakhs, and it is the biggest hackathon in Central India. Once in a year, it happens, and it's a great opportunity for everyone to compete and learn and grow more and move up in their career. I mean, just learn and grow. Participation is more important, so everyone do participate in it. And guys, that was all for today. So basically, what happens in our college is that everyone is interested in software development more. They think that uh, they should do DSA and then a bit of projects on web or Android, and then they should get a job. But there is a very, very little talk in the air about data science, and that is why we did this session to get our students a little more into this field. And the session was really good. Any doubts, you can connect with sir on LinkedIn. So guys, do explore it, and more importantly, connect with people. Connect with them on LinkedIn and interact with them and keep on growing. I mean, the more you interact, the more you open up, then the more you grow, and then the more you succeed. So that's how you do it. So thank you everyone. Have a nice day.